Thank you, Ariane, and good morning, everyone. October is a month in which we celebrate a number of important milestones in aerospace. For example, October 4th marked the anniversary of the dawn of the space age. It was on that date in 1957 that the Soviet Union launched Sputnik 1, the very first man-made satellite, into orbit around the Earth, initiating a high-profile space race between our two nations. 47 years later, on October 4th, 2004, Spaceship One completed its second trip into space in less than 2 weeks, thereby winning the $10 million Ansari X Prize and ushering in what may someday be referred to as the age of commercial space. But this morning, I'd like to start out by focusing on a couple of other October milestones. October 14th, 1947, and October 24th, 1968. The span of time between those two dates was almost a magical period for aerospace research and discovery. On October 14th, 1947, a B-29 Stratofortress took off from Edwards Air Force Base, carrying Air Force Captain Chuck Yeager in an experimental aircraft known officially as the Bell X-1 and unofficially as Glamorous Glennis. After climbing to about 20,000 feet, the X-1 was released from its carrier aircraft, and Yeager lit the rocket engine and accelerated to about 700 miles per hour, or Mach 1.06, thereby becoming the first person to exceed the speed of sound in controlled level flight. Over the next 21 years, we saw flight tests of the Douglas D-558, the first plane to fly at twice the speed of sound, the Bell X-2, the first one to reach Mach 3, and 199 flights of the North American Aviation X-15, the first aircraft to fly at Mach 4, Mach 5, and Mach 6. The X-15 was flown by 12 different pilots, including Scott Crossfield, Neil Armstrong, who later walked on the moon, and Joe Engle, who ended up commanding 2 space shuttle missions. 8 of the 12 pilots earned their astronauts' wings in the X-15 by flying at an altitude above 50 miles. The fastest speed achieved during the program was about 4,520 miles per hour, or Mach 6.7. The highest altitude reached was 354,200 feet. Its final flight was on October 24th, 1968, that other October milestone I was mentioning. And even though most of the general public was focusing its attention on the Mercury and Gemini astronauts and NASA's preparations for eventually landing on the moon, the lessons learned during the X-plane era on topics like the operability of rocket-powered aircraft, stability and control, inertia coupling, energy management, situational awareness, and precision runway landings were invaluable in the development and operation of the space shuttle, and even today are influencing the design of Virgin Galactic's Spaceship Two, X-Corps Lynx, and Sierra Nevada's Dream Chaser. During the X-plane era, it was the government that was clearly in charge. Whether the lead agency was NACA, NASA, the Air Force, or the Navy, it was government employees that formulated the vision, established the programmatic goals and objectives, provided the necessary funding, and generally called the shots. The same paradigm held true for projects Mercury, Gemini, and Apollo, and during the lifetime of the space shuttle. It was the government, in conjunction with their support contractors, who designed, built, tested, and operated all of the launch vehicles and spacecraft that were used. With the retirement of the space shuttle, the likely continuation of highly constrained budgets and the emergence of new markets like suborbital space tourism, the rules of the game are clearly changing. 10 or 20 years ago, there was little evidence of a commercial space industry at all, outside of the launch of telecommunication satellites on expendable boosters. But looking at what is going on today, we can see a whole range of commercial space activities. Let me start by offering a definition of commercial space, since that seems to be a key part of the debates that are frequently held on this topic. According to the National Space Policy, which was published on June 28, 2010, the term commercial, for the purposes of this policy, refers to space goods, services, or activities provided by private sector enterprises that bear a reasonable portion of the investment risk and responsibility for the activity, operate in accordance with typical market-based incentives for controlling cost and optimizing return on investment, and have the legal capacity to offer these goods or services to existing or potential non-governmental customers. To put it into simpler terms, commercial space refers to transactions in which a company is offering space products or services for which they have helped to fund the development. In other words, they have skin in the game. For which payment schemes are typically fixed price rather than cost plus, and for which there's at least a potential for non-government customers. Using that definition, there are at least a dozen current or potential mission areas that are being led or at least significantly influenced by the commercial space sector. Mission area number 1, satellite deployment. Lockheed and Boeing are still launching lots of satellites, along with Orbital Sciences and SpaceX, with new folks like Generation Orbit eager to get in on the act. Mission area number 2, commercial cargo. Both SpaceX and Orbital Sciences have successfully delivered food, clothes, and scientific equipment to our astronauts on board the International Space Station, and are under contract to continue providing that service for the next several years under the Commercial Resupply Services Program. Meanwhile, NASA has issued a request for proposals for a follow-on contract that would potentially add additional suppliers to that effort. Mission area number 3, commercial crew. NASA recently selected Boeing and SpaceX to provide crew transportation services to and from the ISS starting in 2017, with those missions being conducted under an FAA launch license for public safety, and with NASA retaining responsibility for the safety of its astronauts and for mission assurance. Sierra Nevada has asked for the GAO to review that award, and regardless of the outcome, has said that it may end up continuing the development of its Dream Chaser spacecraft, even without NASA support. Mission area number 4, commercial space stations. NASA will be attaching the Bigelow Expandable Activity Module, or BEAM, to the ISS next fall. And Bigelow is currently in the process of developing multiple large standalone stations that could be put into operation as soon as reliable crew transportation becomes available. Mission area number 5, satellite servicing. Vivisat is currently signing up customers for its system, which is designed to be able to provide attitude control and/or orbital repositioning services for geostationary communication satellites and other spacecraft as needed in order to extend their on-orbit lifetimes. Mission area number 6, space tourism. Both Virgin Galactic and X-Corp hope to be able to start suborbital flight operations for paying customers in 2015. And as we heard yesterday, Worldview is planning to offer a similar experience the following year with long-duration, extremely high-altitude balloon flights. Mission area number 7, research and technology. Masten Space Systems is already flying experiments on its reusable suborbital vehicle, And Blue Origin has been talking with principal investigators about the payload accommodations that will be available once their system starts flying. Mission area number 8, spaceflight education and training. Several companies, including NASTAR, Zero G, Black Sky Training, and Waypoint to Space, are offering a variety of space-related training programs, including classroom sessions, parabolic aircraft flights, simulator experience, altitude chamber runs, and time in a centrifuge. Mission area number 9, spaceport operations. There are currently 9 FAA-licensed commercial spaceports in the U.S., and we're currently in pre-application consultations with another half-dozen locations. The most recent spaceport to receive its license was Midland International Airport, and that was a very significant event because it marked the first time that the FAA had agreed to allow a commercial spaceport to be located at a Part 139 certificated airport. For those who are not familiar with the terminology, a Part 139 certificated airport is one that offers scheduled air carrier service. So that is an example of how the FAA is working hard to integrate commercial space operations with other more traditional users of the national airspace. Mission area number 10, point-to-point transportation through space. The technologies that will allow us to travel halfway around the world in just an hour or two are probably several years off. But already, companies like Virgin Galactic and Swiss Space Systems are working on plans to provide such services. Mission area number 11, exploration. You might assume that when it comes to the planning for future exploration missions, the government would be the only game in town. But these days, some of the most innovative and ambitious plans for going beyond low Earth orbit are coming from the private sector. The Google Lunar X Prize is offering $30 million in prizes for the first teams to land a rover on the moon, translate across the lunar surface, and send back high-definition video. Golden Spike has announced that it plans to offer opportunities for scientists and other interested parties to participate in commercial expeditions to the moon as early as 2020. Inspiration Mars has done preliminary planning for a two-person flyby of Mars, starting with the launch in January of 2018. And Mars One, a not-for-profit organization based in the Netherlands, has put forth conceptual plans for a series of one-way missions in order to colonize the red planet, with the first volunteers hoping to arrive by 2025. Now, it is certainly possible that some of these plans will never come to fruition. In fact, it may turn out that none of these efforts will successfully accomplish their stated objectives. But I think the fact that this kind of bold and visionary thinking is coming from private citizens or commercial entities rather than a government space agency tells you something about our current national priorities when it comes to exploration. It also reminds us about some of the innovation and out-of-the-box ideas that the commercial space folks could bring to the table if we give them a chance to participate. Mission area number 12, space-based resource extraction. Looking even farther downstream, companies like Shackleton Energy, Planetary Resources, and Deep Space Industries are seriously examining how to develop the equipment and technologies that would be necessary to mine ice on the moon, or iron, nickel, or other raw materials from asteroids. That makes 12 mission areas in all, in which the private sector is either leading the way or in which it will be playing an important role in some kind of partnership with the government. Some of these activities, including commercial cargo deliveries to the ISS, suborbital technology demonstrations, spaceflight training, and commercial spaceport operations, are already well underway. Others, such as suborbital space tourism and commercial crew transportation, are almost certain to be taking place within the next few years. Point-to-point transportation and some of the more challenging exploration missions may be 10 or more years off, or they may never happen without significant government involvement. But I find the depth and breadth of the things being worked on right now in the commercial sector to be really exciting. And they frankly give me hope for the nation's future in space. So given all of this activity in commercial space transportation, what should the government be doing other than just to get out of the way? I've come up with a few suggestions that I hope will be relatively easy to remember with the help of a little memory trick. As you know, the alphabet has 26 letters, including 5 vowels and 21 consonants. Today, I'm going to focus on the vowels: A, E, I, O, U, and sometimes Y. So what should the government do to enable a robust and successful commercial space industry? Well, I'm not sure how many of you used to watch Sesame Street, but for today, A stands for allow. The government should allow the commercial sector to carry out the mission areas that we've just talked about. That means our laws and regulations need to be written in such a way so as not to prevent informed crew members or spaceflight participants from accepting the risks that are inherent in human spaceflight. The letter E stands for encourage. The government should encourage commercial space activities. It can do that through investment in promising technologies, through partnerships and Space Act agreements, and through being a reliable customer when buying goods and services from the private sector. The letter I stands for inspire. The government should inspire the public when it talks about the nation's space program by communicating an exciting vision, by putting forward challenging objectives, and by developing national policies that can enable private sector progress in space. The letter O stands for oversee. The government should oversee commercial space operations to ensure that they do not put the general public in danger, and that lessons learned and best practices are communicated and incorporated wherever possible. The letter U stands for understand. The government should make sure we understand the science, technology, engineering, and math involved by continuing to promote STEM education and by performing both academic and industrial-based research on space-related topics, such as through the FAA's Center of Excellence for Commercial Space Transportation. Now, sometimes Y is also a vowel. So today, the letter Y stands for yin and yang. The government should be on the lookout for the yin and yang in our industry. According to Chinese philosophy, yin and yang are apparently opposite or contrary forces that are actually complementary, resulting in a system in which the whole is greater than the assembled parts. Examples in aerospace might be encouraging partnerships between large companies and small ones, or between established firms and entrepreneurial ones, or ensuring that our portfolio of space systems includes both capsules and winged vehicles, or both horizontal takeoff and landing and vertical takeoff and landing systems. So that's my recipe for government action: A, E, I, O, U, and sometimes Y. Let's see if we can remember those. A stands for allow. E stands for encourage. I stands for inspire. O stands for oversee. U stands for understand. And whenever we can, let's remember that Y stands for yin and yang. Very, very good. Thanks to all of you for being here today, and for Pat Hines for giving me the opportunity to participate in another outstanding symposium here in Las Cruces. I'd be happy to take any questions that you may have. Thank you.
Thanks, George. That was great. We actually have time for just one.